સાંભળ એટલે હું મારું બ્રીફ ઇન્ટ્રો આપીને સ્ટાર્ટ કરી દઈશ, એની પણ ચિંતા નથી.
હા, ઓકે ઓકે, ઇટ્સ ગુડ. તમે જાતે જ
ધારો કે
મને
તું મને કહે છે કે સર
પૂછશો.
તમારો બ્રીફ ઇન્ટ્રો આપીને સ્ટાર્ટ કરો પ્રેઝન્ટેશન, તો આઈ વિલ બી ડુઇંગ ધેટ, નો ઇશ્યુ.
ઓકે. Kashyap sir,
હા,
now we are online. Our
ફાઇન,
webinar is
ગ્રેટ.
start.
Should I start my session?
Just 2 minutes. Good morning, good afternoon to all viewers. My name is Hetal Prajapati from the Parur University Diploma Electrical Engineer and the head of the Diploma Electrical Engineer. Today we have Kashyap, Dr. Kashyap Mukoya with us for the webinar of circuit breaker applications and all that. So now I will give the I will tell to Kashyap sir to please start your presentation and share your views on circuit breaker. Sir, please start your presentation.
Thank you,
Give
Ethel
me a
madam.
brief.
Thank you, Parul University. Thank you, Polytechnic staff, for inviting me as an online webinar for Breaker. Whatever the viewers who are just really listening me or seeing my presentation, to my teachers who are joining the Parul University, I'll be very honored that I'm giving a session in front of them. To all the dear students from different places of Gujarat, you are heartily welcome. Before presenting the session, I'll just briefing the session that I was working as a maintenance engineer at Reliance Industries Limited. I joined the government services in 2010. Before that, I was head of the electrical department at SCBS College. I was in charge principal at Industrial Training Institute for 3 years. I worked with Mahatma Gandhi Institute. I have all the domains of experience right from the beginning to ITI diploma and degree. And actually, why I thought to give this presentation, say while I was working at Breaker, while the students who are studying in diploma, BE or ME, they only understand that breaker is used for transmission line. No, we have a different role at industry. Suppose Reliance Industries Limited, we have a motor which is rating at up to 90 kilowatt, which was operating by means of a starter. Now we are clearing our doubt here that in book it is written that a starter can be used for a motor up to 5 HP rating only, but those industries, those have their source which is strengthened, or those have those devices that can compensate a voltage deep. They have a dual starter and star delta starter up to 90 kilowatt. So while you end your presentation today, and after the question answer session is over, just write in Google that the LNT or ABB starter, and you will find that reading also. So that thing is clear. The second myth about the starters in industries, that some we think that when we start the induction motor, it takes 5 to 6 times current, and this motor is harmful to the machine. The basic thing is, when you start the motor, whatever the 5 to 6 times starting current as compared to rated current it is carrying, it is creating a tremendous voltage dip. So that source would be strong enough to deal with this voltage dip, because as torque is proportional to V square, you will get a high amount of torque while starting with dual starter. So they are using it, but it is restricted up to 90 kilowatt. Up to 90 kilowatt to 160 kilowatt LT motors. These all motors are classified as LT motors. 0 to 90 kilowatt LT motors means 415 volt supply. 90 to 160 kilowatt LT motor means again it is operated by 415 volt supply. And these we were implementing by, or we were giving it supply and disconnect the faulty part by means of air circuit breaker. For HT motor, HT motor which has a supply of 6.6 kV, that is operated by means of a vacuum circuit breaker. So the diploma holder who will be entering into the industry just after passing, the degree holder or the ME holder, while working as a GET after a completion of the GET, they will immediately have the preventive maintenance of motors, of breakers, of batteries. So operation and maintenance is a big section in industry. Whether you go with Reliance or SR or any huge industry, the operation and maintenance department has big vacancies there. So how do they actually do the this maintenance process, preventive maintenance process for breaker? So when there is where we preventive maintenance depends on number of issues. Then the first one is the vitality of the equipment. Number two, the location of the equipment. Number three, the type of the machine. Number four, the duration. So suppose I have planned a preventive maintenance of an HT motor of 6.6 kV. So for that, first the operation department in an industry, what they will do, they will de-energize the 6.6 kV breaker. Then at the back side, the cable will get discharged, because you have to discharge it by means of a rod. Otherwise, the people working at that part will get affected by shock. And third, and they have to tag a red tag that this device is ready to preventive maintenance. Then after the work permit is issued to the head of the maintenance department, from that the team is formed. The team of maintenance department of 2 to 3% will come, and first initially they will go to the motor section and do the preventive maintenance, and after that they will come at the MRS substation where the breaker is there, and they will do the preventive maintenance techniques of breaker. So what to do in this preventive maintenance techniques, what is a breakdown maintenance, what is a type test, routine test, all these things are a part of the today's presentation. This was a brief introduction. I have considered that how to select the rating. Suppose if somebody tells me you have to select a rating for dash location, then how will you select? How to select the recloser? Because in industry, the people want solution immediately. That how do you bring out the solution to them immediately? So the basic things we study in the book. Now, if we compare it with the industrial section, then what updations we have to do, that all these things I have covered in the presentation. You can just see circuit breaker basic, arc isolators, breaker ratings, IEEE standards for selection of the breaker, different types of breaker. In the last slide, I have covered the application through the voltage rating of different types of breaker, then recloser, sectionalizations, and direct and indirect testing and other testing methods in the industry. So I hope it will be very useful to the viewers who are listening. And after this presentation, I'll be attending the queries on my email, and I'll be sending some useful videos of industries for this. So breaker is a piece of equipment which can make or break a circuit either manually or by remote control under normal conditions, break a circuit automatically under fault condition, make a circuit either manually or by remote under the fault condition. So it consists of a fixed and moving contacts called electrodes. Under normal operating conditions, these contacts remain closed and will not open automatically unless the systems becomes faulty. These contacts can be opened manually or by remote control. Say I'm using a word now, a remote control. It means that in the control room, the operator is sitting. From his panel, he can shut off your breaker. Even he will not visit the substation there or site there. So that is there, and the prime requirement of the maintenance engineer is he or she should be able to read the readings. That how to just trace the control circuit. That is also one of the part of the preventive maintenance, that they have to testify that this circuit is working okay, and in future it is working very nice. By final fault occurs in the circuit, the trip coils of the circuit breaker get energized and the moving contacts are pulled apart by some mechanism, thus opening the circuit. Say this is a very basic diagram, but if I want to modify this diagram, what I will be doing, I will be placing here a contact here. Suppose a DC source is there. A DC source, a control circuit. In industry, generally the control circuit is 110 volt DC. So that it is supplying to trip coil. And now say I have taken an example of induction motor. Now you just assume that induction motor overload setting has a different setting. Induction motor short circuit setting it's a different setting. So what we do for, suppose say, instantaneous settings for motor should be tripped within 3 cycles. For that, whatever the rated current is, suppose my motor rated current is 132 ampere. So that 132 ampere into, suppose say, 6 is my starting current, divided by 0.75 to consider that less voltage, to consider the amount of the starting current, because breaker should not trip on that starting current. So it has a different requirement. Now consider the other load setting. In O load, it is a different setting. But the thing is that all the contacts in an industrial control circuit will keep in parallel, and one of the normally open contact, if it gets close, it will directly operate your trip coil while this DC supply is on. So now you can visualize this diagram. So one breaker is looking care for a different amount of volt of action motor, or if we compare it into the feeder action, then also it will give the tripping against the fault. So this is the some very basic things about the circuit breaker. Now, if I keep it very simple, there are two types of arc extinguishing principles: a high resistance interruption and a low resistance interruption. Take an example of a DC circuit breaker. So when or an air circuit breaker, when the contacts are separated, the arc will be formed like this. The reason is that when the contacts are separated, a potential difference is created between them. If the voltage between contacts is more than the dielectric strength of medium, the ionized air acts as a conducting path, and hence the arc is struck between contacts. The arc between contacts act as a resistance value known as an arc resistance. Greater the arc resistance, smaller the current. It depends on degree of ionization. That as the ionized particle between the contact decreases, the arc resistance increases. Length of arc, as the separation between the contact increases, the length of the arc increases. And cross-sectional area, as the arc resistance increases with decrease in the area of cross-section, your arc resistance, if cross-section area increases, the resistance decreases. Now pick up the point length of the arc. Say what they are doing in 440 volt LT breaker that was rated from operating a motor of 90 kilowatt to 160 kilowatt. I have to lengthen the arc through my arc tube chamber that I'll be showing in the presentation later, and through that process I am increasing my arc resistance of the breaker, and through that I am extinguishing the arc. But imagine if that the lengthening of arc process, can it be useful for the high voltage breakers? The answer will be no, because if you lengthen the arc means you put your fixed and moving contact at a particular distance, or you put that splitters there, your size will be uneconomical. So those high voltage breaker will be very bulky in the size if that voltage rating has been increased to take care of these things. So again, I'm repeating, the lengthening of arc, the high resistance interruption method is used for an 450 volt air circuit breaker, or it can be used for some DC breakers. For the AC breakers, just like vacuum breakers, Airblast circuit breaker, we are using the current zero interruption phenomena, that when the current passes through a 0 point, we have to build up our rate of rise of dielectric strength. That will definitely take care of the arc extinguishing. So DC arc are to be interpreted by increasing the resistance interruption method, and with resistance of arc is increased, size of the DC breaker increases as the voltage level increases. AC arc current reduces to 0 in each cycle. If the circuit breaker contacts are open at time when the current passes through 0 and dielectric strength of the medium is built up, then the arc can be extinguished. So both have a different principle. So I have just covered this high resistance and low resistance method here. These are the basic definition. From basic, I'll be switching towards the design and exit process during this presentation. Say arc voltage is a voltage that appears across the contacts of the circuit breaker during the arcing period. Recovery voltage, it is a normal frequency voltage that appears across the contact of the circuit breaker after final arc extinguishing. And RRW, it is the rate of rise of restriking voltage. Generally, it is given in kV per microsecond. Now you can see here, what is restriking voltage? It is a transient voltage that appears across the contacts at or near current zero during the arcing period. So you can see at this current zero, you will see in my PPT that this restriking voltage is there. So once this restriking voltage goes off, you will get the normal frequency voltage, that is your recovery voltage. But in between, you have to perform that methods whether it is a high resistance interruption or whether it is a low resistance interruption, as according to the AC, or it is a DC breaker. One thing that is asked in interviews in industries also, when you apply for that, and in some final years examination also, that what is current chopping. It is a phenomenon of current interruption before the natural current zero is used. It occurs in Airblast circuit breakers because they retain, you will find in some of the VCBs also, that it occurs in ABCB because they retain extinguisher power irrespective of the magnitude of current to be interrupted. When interrupting a low inductive current, magnetizing current of transformer, a rapid deionization effect causes the current to fall below its zero value before natural current. This is basically known as a current chopping. Now, where do you find this Airblast circuit breaker? We daily move in trains. We will find the Airblast circuit breaker fitted on the roof. So these ABCBs are there. Now, the logic behind it, that why that traction people preferred Airblast circuit breaker, because in trains, to run the wipers, to raise your pantograph, you need a air. For Airblast circuit breaker, also you need an air. You need a reservoir for that. You need an air for that. So the reservoir stock of air is doing a multiple purpose there. So that's why in traction in India, generally we find an Airblast circuit breaker fitted at the roof. So here what we are explaining, that before the natural current zero, if my current is chopped earlier, then definitely it will produce the TRV. It will produce a transient restriking voltage. So we have to find a remedies of this. We have to solve the issues regarding the current chopping in such type of breaker, and this is one of the methods. What in resistance switching, what they are doing actually, initially when your breaker is on, say this switch S is closed, so your resistance will be in the picture. Due to that resistance, you will having an absorbing an energy that was due to that arcing period, and try to pick up that phenomena that which was causing the TRV due to the current chopping before the natural period. So here you can see I have plotted some oscillating restriking voltage when the recovery voltage is reached, when the damp restriking voltage is reached, and a bit explanation I have written here. So the switching resistor R is connected in parallel with breaker. Current chopping produces high voltage oscillation, which can be prevented by this method. During arc interruption, circuit breaker contacts separate first and after arc get extinguished as opens depending upon the time delay. So time delay has to be properly evaluated. When the fault current occurs, the circuit breaker contacts open and arc is stuck between them. So R is in parallel with CB contacts. A part of R current now flow through the resistance. So the R current will get decreased because you have a parallel path through your R in parallel to the breaker contacts. So the arc resistance also increases, so current through R increases. This continue till the R current is insufficient to maintain the R. Thus, how we can deal with a current chopping phenomena. Now, in industry, this is very important that you should know what is a breaking capacity. It is the current that a breaker is capable of breaking at a given recovery voltage and under specified condition. Take an example in industry. If one breaker is of 100 MVA capacity and its service voltage is 33 kV, so 100 into 10 raised to 6 is equal to root 3 into 33 into 10 raised to 3 will give you the breaking current from your breaking capacity. Breaking capacity is always given in MVA, and from that the breaking current is deduced. The making capacity, the peak value of the current including the DC component during the first cycle of current waveform after the closure of the circuit breaker is known as a making capacity. Making capacity is 255 times symmetrical breaking capacity. I will share you that why this making capacity should be higher than the breaking capacity. The reason is that, say, when you perform a recloser operation or when you close your breaker on fault, when you make the circuit on fault, you have to deal of that much amount of high current as compared to the breaking current. That's why the making capacity of a breaker is 2.55 times the symmetrical breaking capacity. I have put one note here. So the peak value of the symmetrical breaking current is 1.414 into I. During the subtransient period when the DC current is also present for 1 or 2 cycles, so the peak value of current during the subtransient period will be 1.414 into 1.8. So that will give me the figure of 2.55 I. Through the 3 states, your phenomena will pass. The subtransient, then transient, and the steady state. But once it is hitting that subtransient phenomena, where that time the current is very high and the reactance is low, it is vice versa. Like the subtransient reactance is low, then the transient one, and then the steady state. So you have to design your breaker according to your subtransient state, and that I have covered in the presentation, that how to take care of that. Because once you design your breaker on the steady state conditions, it will be an false arrangement, because it will not take care of that high inrush, and there are every chances that the breaker contacts might get damaged. So this was related to some basic related breaker. Say I have shown one example here. IEEE standards for selection of breakers. Calculate the highest value of initial RMS current considering symmetrical fault. The current can be obtained by subtransient reactance of synchronous generator and transient reactance of motors, and induction motors are selected. Following multiplying factors are applied to take the DC components into the action. So I'll be direct going to the example. To determine the rated momentary current with time 1 second or less of breaker, the calculate of highest value of initial RMS current can be done as given in step 1 without using the subtransient reactance of all machines, including induction motors, and multiply that value by 1.6 as according to the IEEE. Now here is the example that is giving me a clear picture. So once some digital people met me and they told me, sir, what's your thought that how there are how many methods that we could predict the capacity of the breaker. So this is one of the methods that we can predict the method. And once our diploma engineers and degree engineers and ME persons are deputed at the industry, they have to directly execute the data that it is given that this breaker has arrived at the industry, and we have to do commissioning tests, and then quickly we have to move towards different types of settings. So suppose the rated normal current is 150 ampere, braking capacity in MVA is 1000 MVA. So I got the symmetrical braking current. By multiplying it by 2.55, I get the peak making current. Remember that the making current always we have to consider a peak value. Short term reading means that the rated symmetrical braking current, for how much time it can withstand. So suppose if it is withstanding that symmetrical braking current for 3 seconds, then it means that my short time capacity of the breaker is 3 seconds. And obviously the rated service voltage of 33 kV. We were working in the industry on vacuum circuit breaker which were rating of 33 kV. Now I'll explain one case of industry that the motors, the VCB were operated for 6.6 kV. But what was the structure in the company that from Ichhapur line 1 and line 2 we are getting to incomers 220 by 33 kV. So, and we have at that time 8 generators of 30 megawatt. That those were gas turbine generators. So 11 to 33 kV step up transformer is there. 220 to 33 kV step down transformer is there. It means that in whole plant at whole MRS 1 to up to 8, 9 substations, we have the breaker of 33 kV, which was the vacuum circuit breaker. And engineers has to deal with the preventive maintenance and maintenance of these breakers. So in my tenure, I have gone with the frequent maintenance of ACBs and BCBs very in very fast period. While SFC's breaker was in switchyard, so wherever we take the preventive maintenance at switchyard, then those things will come into the picture. Now very important. I have shown the slide. What that was a query of one of my friends from GEV. So you can see the ST double dash, the substantial reactance is 10%, transient 16%, and XD is equal to 100%. A generator connect through a 5-cycle circuit breaker to transformer is rated 8000 kVA and 13.8 kV. Then find the sustained short circuit current in the breaker, initial symmetrical RMS current, maximum possible DC component in the breaker, current to be interrupted by the breaker and the interrupting kVA. So short circuit kVA, I have already given that my kVA is 8000. So from that, and my XD is suppose say 100%. From that, I get the data of this 8000. My short circuit current is equal to kVA into 10 raised to 3 by root 3 VL. Or if it is this is in kVA and this is in kVA, I don't have to put the figure there of root 3. So sustained short circuit current I get from my basic data. It is 334.70 ampere. Now I can see the subtransient short circuit kVA is equal to 8000 by 10. I'll go to the back slide. What is 10? 10 is your XD double dash. That I shown that your initial phase that breaker has to take care was this subtransient period, and this period is very lethal because breaker has to go through it. So that value comes into multiply by 100. That value comes somewhere near 80,000. So subtransient or initial symmetrical current. This is the kVA capacity. So I get the symmetrical current is equal to 3347, And if somebody asked that what was the DC component from this current, so I got the maximum possible DC component is equal to root 3 times root 2 times the peak value from this. So I will get 4732.73 ampere. So I get the momentary current rating is 1.6 into my subtransient. Because why I said it momentary? Because your subtransient state of the breaker is for 2 or 3 cycles only. So 1.6 into 3347.05. So it is 5355.28 ampere. Current to be interrupted is equal to 1.1 into 3347.05. So I'll get 3681.75 MV. And now somebody tells you, now you find the capacity of the breaker in kVA or MVA. So I'll get the equation now, root 3 into the current to be interrupted, this much 3681.75 into your service voltage. And now you are coming that for this type of specification of the breaker, you need a 87.99 MVA breaker, or perhaps an 88 MVA breaker. Now coming back to that GB person that he was asking that, sir, this is one of the method. Is there any other methods? Another method is that in power system, what we are doing actually, we are planning some, you are assuming some base MVA with certain assumptions, and then we get some per unit reactance. We draw the equivalent diagram from that, where the for generator, transformer, and all those things, and from that also we can deduce the data. But this is very important for me because I am directly hitting that. I am directly keep watching on my subtransient or initial symmetrical current. The third thing is that some people think that in MATLAB, suppose I want to visualize that at this amount of high voltage line and this rating of breaker, that how I will for this fault current, three phase dead short circuit currents, how my waveform will look, what will be its effect after a particular simulation runtime of millisecond or in second. So in MATLAB also people can plot the responses by taking a nominal T method or nominal pi method. You can have a generator, you can have a transformer, you can have a load as an induction motor, you can have a breaker, you can have a fault block, and you can just visualize the rating. But surely you have to calculate and deduce this type of ratings when you are in the industry, that what will be your ratings of the breaker which is in the, it has to be fitted. So requirement of CB is the normal working current at a short circuit current must be safely interrupted by the breaker. The faulty section of the system must be quickly isolated while keeping minimum delay. The faulty circuit must also be isolated without affecting the healthy one. So these are the points. Classification of the circuit breakers according to the service. It is an indoor breaker and the outdoor breaker. So what this was our experience at industry. At indoor breaker, we were comfortable for doing PM because there is a room, there is an indoor breaker. We have to latch the breaker from its rack, and maintenance was a bit easy process there. But the care should be taken that if operation person has forgotten to de-energize, the maintenance person has to go at the site. They have to visualize that rat tag of preventive maintenance should be fitted. If it is not fitted, don't start your work because it will create some problem. Second thing, don't touch the breaker directly. At the back side, maintenance person will again go, they will discharge the cable, and once they confirm that the supply is off, the cable is discharged, and then the preventive maintenance team will start working. Interrupting medium, way of operation. Which type of interrupting media is there? Air is there or SF6 is there? Tank construction, whether it is a bulk oil or a minimum oil. Way of mounting, whether it is a horizontal mounted or a type of contacts. What are the different types of contacts are used in breaker? So here I have included all in general classifications of the breaker which are used in industry. According to the interrupting medium, the circuit breaker are classified as air breaker or air circuit breaker, Airblast circuit breaker, oil circuit breaker, or a magnetic circuit breaker. According to the service, they are used as indoor or outdoor breaker. Depends on the operation of type of circuit breaker. Are gravity open, gravity closed, and horizontal back circuit breaker. On the basis of the action, circuit breaker are classified as automatic and non-automatic circuit breaker. According to the method of the control of the circuit breaker, it may be directly or operated remotely. This is very important feature. In most of the industries now, bigger industries, all the breakers are operated from control room. So even you do not require to go to site there. But yes, the operation department person has to go on site because he has to discharge the road. He has to discharge the cable by the road. So that's why you have to go to the site. The way of mounting classifies the circuit breaker into panel mounting, rear or panel or remote from the panel. On the basis of contacts, the different type of circuit breaker are butt type contact, wedge, laminated, flat contact, explosion chamber type. These are the different types of contact which are used. Out of the various ways of classification of circuit breaker, the general way of classification is on the basis of medium use for arc extinguishing, oil circuit breaker, SFC circuit breaker. So these are the different types of classification. I want to share one experience of my preventive maintenance. So one, I was working at ACB. We got the phenomena that my 3 poles of the breaker are not closing or opening at a time. Now this creates a big issue because my 415-volt breaker is connected to an LT motor. So if I kept remain this problem as it is open, then what will happen? Say R and Y will close, and from a millisecond or microsecond time lag, my B phase will get closed. So obviously it will directly cause a single phasing to my machine, and it will, if my preventer relay is there, obviously it will trip the machine. So, and these things are cannot seen as visualized, but these things comes from experience. So we come to know that something is misleading there while preventive maintenance. So what actually in your book testing commissioning and stuff, they have suggested a lamp method, that either while closing or opening operations, all lamps should be closed simultaneously or all lamps should be off simultaneously. But what actually we did at that time, we put a carbon paper in the 3 poles, and we plotted the image simultaneously of closing or opening. And from that image, we come to know that there is a little lag found in the waveform in the beat phase. So that was the solution we got from the analysis, and immediately the maintenance people rectified the problem. The assembly was repaired, and again the pole closing mechanism was observed. And after 3 hours work, it was again kept back into service. So this is air circuit breaker. The diploma engineer as a DET or the degree engineer as a GET, they have to face this breaker very early in their career, because it is used for 415-volt low tension motor from 90 kilowatt to 160 kilowatt rating in industry. So in this circuit breaker, the arc is elongated using the arc runners and arc meters. This increases the voltage required to maintain the arc. At current zero, the recovery voltage across the contact becomes less than the arc voltage, and the arc gets extinguished. But it is important to see from figure. Say, from figure you can see here that this 2 number, it is your arcing contacts. This is your arc runner, 7 point. So I have already told before starting this presentation that I will send you all individual videos of all the breakers through Hital madam. That while seeing this construction, you will get the video also, and the doubts can be clear. You will see here some arc plates are here. So what they are doing here, you can see they are lengthening the arc. But the principle which is used in a DC breaker or in a low voltage AC circuit breaker, can it be used in high voltage breaker? No, because for high voltage breaker, if you use the same phenomena of lengthening the arc, your size of the breaker will be very high. So in the early slide, I was using the word arc runners and arc splitters. So arc splitters is this 5th number. We have a multiple plates here: plate 1, plate 2, plate 3, plate 4, plate 5, plate 6. And when the through arc runner, your arc is enter into the splitter zone, it due to the R is equal to rho L by area, due to the lengthening of arc, it starts cooling. So this was a basic principle of an ACB which was used for machines, LT motors for 90 to 160 kilowatt in breaker, air circuit breaker. So used for low voltage levels. As voltage levels increases, the size of the breaker becomes large, so as to not convenient for high voltage and current levels. Air is used as medium to extinguish arc, which have inferior extinguishing properties. Obviously, air has an inferior extinguishing properties because we have used a natural air for our remedy. We are not using a compressed air or a high pressure air, just like Airblast circuit breaker. We are not having a superior properties just like SF6 or vacuum circuit breakers. So these are rated up to 1000 volt. Practically, I have worked in industry on this breaker, which were rated at 415 volt. So suitable for remote operation because medium of arc extinguished air, so commonly used in industrial switchgear, and everywhere you will find. Once the DET after passing and GT after passing will join the industry, they will have to soon deal with this type of breaker. Airblast circuit breaker. In this breaker, a high pressure air blast is used as an arc quenching medium. The contacts are opened and the flow of air blast is maintained by opening the blast valve. The air blast cools the arc and takes away the arcing products to atmosphere. This rapidly increases the dielectric strength of the medium between the contacts, and the arc is extinguished and the flow of current is interrupted. So this is the assembly. This you can find on the traction application. Say in the front view, you can see the number of things. You can see this operating mechanism. You can see this 7 number. It is a fixed contact. You can see the separation of the fixed contact and moving contact. This is your fixed contact. This is your moving contact. Say you can see this chamber 13, very important to me. What I have shown you, this is the resistance switching unit that I have discussed. That due to that current chopping phenomena, you have this type of resistance switching unit in your breaker. It might be this type of a simple unit, or it might have a multiple unit connected in the air blast circuit breaker. So this figure gives you so many things, that the 10 number, this is your compressor spring. It will the pressure or force of the spring will decide this movement of fixed contact and moving contact. So all these things, but once in industry, or once somebody is working in the railways in future, so they will have an exposure to deal with this type of air circuit breakers. You should have a pneumatic operating mechanism where the compressed air enters here. So all those things are shown here. Now this is a very simple slide. According to your airflow, the direction of the airflow with respect to this arc and the contact, it is given as a radial flow. Either it is a perpendicular, or it can be negative flow. The advantage and disadvantage: high speed of operation of air blast circuit breaker, short arcing time, high speed reclosing. Now reclosing I will be covering in depth in this presentation. What is reclosing? Suppose a bird is sitting on a transmission line, or at that time of Makar Sankranti or the kite festival, somebody has a kite thrown out at the line, and suddenly it is taken back. But at that moment, it created the fault, and your fault was gone. Now what happens that in this case, if your breaker is permanently tripped, then again you will have a time to restore it. So your breaker will have a 3 or 4 more shots of close open operation. Say close open, close open, close open, and it will check that whether the fault is gone or whether the fault is existing. If the fault has already cleared, then it will permanently close the breaker. If after that 3 cycle operation, if your fault is persisting still, then your breaker will assume that something bad has gone. It is not a transient fault. It is not a fault like some bird is sitting on the line, or some tree has fallen on it. So this is a typical case of where the reclosers are there. So in this presentation also, the design of or ratings of the reclosers also are there. Operation and maintenance of highly skilled persons are required, because you have to deal with a number of things. You have to deal with the compressed air, you have to deal with the reservoir, you have to deal with the resistance switching unit, we have to deal with the moving assemblies of that. But through my experience, I can tell you that once 1 or 2 times you have a good handhold experience on any type of breaker, then obviously in future you can be working with it very comfortably in future also. So this is the advantage and disadvantage. This is the axial flow breaker, that as compared to radial flow, I just show you the direction of the air here, how that air is blown, because the rate of the dielectric strength will build up, and obviously your arc will get extinguished. So axial blast circuit breaker, air is admitted in the arc extinction chamber, it is pushed through moving contact. This air blast takes away the ionized gas along with it. Afterwards, the arc gets extinguished. High pressure air has a higher dielectric strength. The design of such type, the air expands into the low pressure. The R at high speed removes heat from the arc. Thus, arc is stretched and diameter of arc is reduced. It uses in arc furnaces and traction system. In interview, in industry, many times you will be asked the application. Air blast circuit, say air brake circuit breaker. You will quickly say that it is used for an LT motor for 90 to 160 kilowatt rating. Starters. So it has an application. In the book, it is written that starters can use up to 5 HP. But in industry, up to 90 kilowatt, the starter can be used. But the source should be strong enough to deal with the problem of a voltage dip. Third, Airblast circuit breaker. It is specifically used in a traction systems and it is used in an arc furnace. This I was talking to you. See, you can see here the resistor unit is different than the previous case. So you have a multiple resistor unit in this type of Airblast circuit breaker. So this is a modified version of a simple Airblast circuit breaker that is used. Advantage: no fire hazards are possible with this type of breaker. The high speed operation is achieved. The time for which arc passes is short, thus the arc gets extinguished early. As arc duration is short and consistent, the amount of heat release is less, and the contact points are burnt to a less extent. So the life of circuit breaker is increased. The extinguished medium in this type of circuit breaker is compressed air, which is supplied fresh at each operation. The arc energy at each operation is less than compared with oil circuit breaker. So Airblast circuit breaker is most suitable where frequent operation is required. This type of circuit breaker is almost maintenance free. It provides facility of high speed recloser that I already discussed, and the stability of the system can be well maintained through this Airblast circuit breaker. Disadvantage: if Airblast circuit breaker is to use for frequent operation, it is necessary to have a compressor with a sufficient capacity. You must be having a compressor. The maintenance of the compressor and other related equipment is required time to time. The leakages of air in this system has to be checked. The pipe fitting arrangement has to be checked. It is very sensitive to the restriking voltage, thus the current chopping may occur, that already we discussed. And the resistance switching unit as shown in the slides that was fitted to deal with the phenomena. Vacuum circuit breaker. Most diploma engineers, degree engineers, and masters, and the engineers who joined the industry after their masters will immediately face this breaker also, vacuum circuit breaker. So when two components of the circuit breaker are separated in vacuum, an R is struck and the hotspots are formed on the surface of the contacts. These hotspots produces metal vapor and plasma. The amount of vapor in plasma depends on how rapidly the vapor is emitted from the contact surface, which depends on the current, on the arc current. So, due to these superior properties of the proportionate of producing the metal vapor as per the arc current rating, it has a very fantastic arc quenching capabilities for a particular rating. In the industry which I was working, we were using this VCB for operating 6.6 kV high tension motor. Again, I am repeating, the ST motors was rated for more than 160 kilowatt, and it was having a supply of 6.6 kilovolt, and we were using a 33 kV breakers for distributing the electricity on the whole industry campus by means of the VCBs. The current is of alternating nature, it passes through zero several times, so the rate of vapor emission also becomes zero, and the vapor already emitted get condensed. During this process, the dielectric strength builds up rapidly and recycling of arc is prevented. So all these things are very important. This is a very basic figure of a VCB. A metallic below is there. I am showing in the subsequent slide an advanced figure that which contains all the parts of the VCB and what we were doing in preventive maintenance at the industry and what the students has to be do in industry. The fixed contact is shown. This vapor shielding unit is shown. Now this is a closed assembly. From outside you can see a closed assembly. You can see the white bottles of vacuum. The level of vacuum is measured in torr. Generally it is 10⁻⁶ torr in VCB. So all those things are there. Say I have shown the front view. Now those people say in suppose what the meaning of presentation is, while you study in your curricular or syllabus, you might not be able to see all those parts, and while somebody has done maintenance of this type of breaker, can easily explain all the mechanism here. So you can see here the open close auxiliary contact standards. Now say what happens when we got the work permit to work on VCB, we were told that कि आपको सबसे पहले क्या करना है, तो आपको जो ये पूरा ब्रेकर जो है उसको यहाँ से आपको एक जो टेक्नीशियन है जो ITI या डिप्लोमा होल्डर्स है उनको ये काम करना है, उनको ये साफ करना है पूरा असेंबली. यहाँ पूरा डस्टिंग हो जाता है जब हम इसका कैबिनेट ओपन करते हैं तब. So first you clean all this assembly. Second thing, ब्रेकर का ऑन ऑफ ऑपरेशन के हिसाब से, वेल योर ब्रेकर इज ऑन ऑफ और ट्रिप, ऐसा हो सकता है कि ये जो असेंबली है उसमें से कुछ वॉशर्स या कुछ चीजें हैं वो नीचे गिर जाए. तो आप जब प्रिवेंटिव मेंटेनेंस के लिए जाते हो तो आपको पीएम शीट में वो लिखना है Okay, when I opened the breaker, some assemblies or some washers were found, and the mechanism was found loose, and I tightened it with my team. वो आपको preventive maintenance sheet में लिखना है. Now you can see here the closing push button. You can see the shunt trip release. We have two types of releases. A shunt trip release is there. The under voltage release is there. Under voltage release operates on 70% or 80% of the voltage level. Then we have a locking magnet here. We have this spring. You can show. So this spring charging mechanism has two parts. One is a manual spring charging by handle, and second is by means of a motor operation. Now, once you start your motor of a servo motor or any motor with a 110 volt DC motor, suppose, with your close button, then immediately you will find that these springs are charged, and it will be in a ready position to operate. Ready position means either you can close the breaker or you can trip the breaker. So all these assemblies, the counter operation is there. In your studies, you are studying that we have to see the mechanical operation or of the breaker. So in what they are doing, they are just says I want to after manufacturing, I want to test that my breaker assemblies are joined perfect. So I will test my breakers, say suppose 1,000 times on off mechanism, and I will see that all the parts, all the washers, all the springs are in intake position. Nothing damage is gone through the breaker. So all this basically industrial tests are classified in type tests, routine tests, then special development tests, and commissioning tests. Type test is performed on a particular lot of breaker. Say when I worked as a quality control engineer at Uniwork Corporation, we were supplying those starters. It was a tubeless starters to an industry at UK. Now, what was the case there? That in my lab, they bring a sample of say 5 starters out of a load production of 100. And if out of the 5 starters, if one starter also fails during I increase my voltage to the kickoff voltage, then I will write in remarks that please reject the whole lot of starters. So you can see the seriousness in industry while they are producing something in competitive market, that if one starter has gone faulty, all the starters, all the lot of starters has been rejected. They were rejected. So type test, in type test, the breaker has to pass the type test. The selected breaker has passed the type test, the routine test. And then the inquiry will come that at that production lot, who was there, what was the production care taken at the time in industry, and all those things will be noted. Now for routine test, it is done for all individual breakers. The routine tests are performed, and it is for healthiness of the breaker. Commissioning test. Once the breaker is dispatched from the industry, it comes at your industry. Suppose my industry, it enters at the gate, then the particular department person will be called. It will not be immediately on the site. Any type of device in electrical engineering, whether it is a breaker, a battery, or motor, it is first put in the storage yard. In the storage yard, sufficient cooling arrangements are there, sufficient cleanliness are there, and then after, at the date of commissioning, the breaker is put on site. After that, the subsequent commissioning test has been noted. After those commissioning tests, the reports are sent to the authority of the functioning. During this commissioning test, if something gets wrong while the test, immediately that manufacturer has been informed that, sir, we find this type of things in a breaker, please recorrect it. And it is majority done in every type of equipment. The fourth category is a development test. In development test, what happens that I suppose I am a manufacturer, I am an industry person, and I want to purchase one breaker. So it is my particular load requirement that my breaker should be withstanding this temperature for this duration. So I'm saying I'm giving a temperature dependability. Obviously, it is the breakers are classified as according to your temperature classification as indoor or outdoor application, that is there. But now there is a specific requirement from my load. My breaker should be like this, and it should clear like this. I have doubt in my mind that my load will not properly get up to this breaker. So the test which I suggested, it comes in the development test. Not necessary that it is mentioned in the starters, because it depends. It is not mentioned in the standards because it is my view of conducting the test. Now this view will give you this bottles, vacuum bottles. that how it looks. And this is that assembly. The front view is there, the back view is there for that. It consists of a fixed contact, moving contact, and R sheet mounted inside a vacuum chamber. The movable chamber is connected to the control mechanism by means of a bellows. This enables the permanent sealing of the vacuum chamber so as to eliminate the possibility of leakage. The glass vessel or ceramic vessel used as outer insulating body. The arc shield prevents the deterioration of the internal dielectric strength by preventing the deterioration of the internal dielectric strength. So outdoor application where maintenance is required, I generally work in industry for two ratings, that is 6.6 kV and 33 kV for VCB. So when two contacts of circuit breaker are separated in vacuum, arc is struck and hotspots are formed on the surface of the contacts. These hotspots produce metal vapor and plasma. At current zero, the rate of vapor emission becomes zero. The vapor already emitted gets condensed, and hence the dielectric strength is built, which can take care of your arc. Advantages: compact in size, obviously very compact, reliable and long life. Heavy fault can be interrupted effectively. No gas is generated after arc extinction operation. Operation is not noisy, very quieter operation. Arc energy is low, no risk of fire. Disadvantage: vacuum has to be maintained at a desired level always. So in the vacuum bottle at the bottom side, there was one white spot or dot, we told in industry. So when we go for a preventive maintenance, we were told that whatever the vacuum level you just see while your visual observation, that you have to note it in PM sheet that whether vacuum level was okay or not. And according to my remarks, the concluding actions were taken. I want to share one experience of industry that resulted in a fatal accident. Say what happened one time that there was an indoor ACB. If you open the indoor ACB, at that time at the jaws of the ACB, which was connecting to the door of the ACB, if that jaws struck at the door mounting mechanism, the door will automatically open. Now, once a time, what happened? The right hand side jaw was broken, and faculty thought that, or the person who was working, it thought that in an industry that I will put one screwdriver there, I will put inside and try to open the window from my right hand, and I will push the breaker inside from the left hand. Now, what happens if he did this type of thing? Then he has to be careful that he has to mount a tap around the breaker, and the tap he should be careful, because once we put some screwdriver and mechanism, I have heard this from one of the friends, then it is possible that your R and Y or Y and B can be shorted by means of that screwdriver. So this type of when you deal with a particular voltage and high current level, we are very careful. Now the automatic door mechanism are already updated in industry, since that after that phenomenon already 10 to 15 years has gone. This is basically an oil circuit breaker. I will quickly go, because until if I don't finish it quickly, the important design aspects and testing might not be over. So this is a fixed contact. This is a moving contact of oil circuit breaker. This breaker makes use of oil for quenching. It has two types of breaker: a minimum oil circuit breaker and a bulk oil circuit breaker. The circuit breaker which uses more oil, which is bulky, is called bulk oil circuit breaker. Remember, oil is used as an arc interruption media, and oil is also used as an insulator here. In case of minimum oil circuit breaker, the majority of the insulation is done by the porcelain unit. So you have very less oil there. That's why it was named as an MOCB. For BOCB, major part is covered with oil, a transformer oil. Suppose the construction is simple and it consists of a fixed and moving contacts enclosed in a strong weather-tight earth tank containing oil up to a certain level and air cushion above the level. So this is basically the OCB. Under normal working condition, the fixed and moving contacts are closed. On the occurrence of the fault, the moving contacts come down and arc is struck. The oil between the contacts get decomposed and hydrogen gas bubbles. Those who have studied the Buchholz principle, you can see this. The phenomena of hydrogen gas bubbles is formed around the contacts. The hydrogen gas cools the arc, and the turbulence effect causes the lengthening of the arc, and the de-energy of the medium between contacts takes place. And at some critical length of gap between the contacts, the arc is established. The thing which we found here, the maintenance on OCB is bit more. Why? Because once you have a decomposition of oil, or you get the carbon particles in the oil, which is known as a carbonization in industry, you will have to test that oil. Just you are checking the BDV of that oil. with that spear gap arrangement and oil testing gate. You have to send in a testing department to get the report. So these type of things were in routine preventive maintenance of your oil circuit breaker. Even when we were doing a transformer preventive maintenance, the first step was we were taking a sample of oil from a drain valve and we were sending it to a CS plant at that time. It was a central testing plant, and immediately the report of BDB was arrived at the department after say 2 or 3 hours, and then we take a decision that whether we have to filter the oil or we want to replace the oil. So once after filtering the oil, even still we do not get the proper BDV, the dielectric the voltage 30 kV per mm, then we take a decision of replacing the oil, and it takes time. If we take a decision on oil replacement on a transformer in industry or in a breaker in industry, it takes a huge amount of time. So the hydrogen gas bubble produces a very high pressure in the oil. The tank is therefore made strong to withstand a large pressure. The oil moves upwards when the hydrogen bubble is formed. The air is present between the oil level and tank up and act as a cushion and absorbs mechanical shock produced due to the upward oil movement. So, bulk oil circuit breaker. Oil has a dielectric strength. Oil absorbs arc energy, good cooling properties. It acts as an insulator between the live part and earth. Disadvantage: long arcing time. As compared to the properties of SF6 and VCB, you have a long arcing time here. The arc will sustain for a quite long amount of time. Do not permit high speed of interruption. Now, if you are thinking a recloser operation with an OCB, you will be getting the result that yeah, in this it will not permit a high speed of interruption. Arc interruption control can be obtained only by increasing the length of the arc. Fine. Now the length of the arc was due to that turbulence action and hydrogen gas when it get occupied in that space between the fixed contact and moving contact, and it lengthened the arc path. This was the reason. It is different from that reason of arc splitter which was used in an air circuit breaker in industry. So both has a different media to operation. This is a typical circuit of an MOCB. Now, why I decided to give presentation on specific on breaker only? Because I felt that when the diploma engineers, degree engineers, and engineers after passing their masters enter into the industry, they directly have to. I directly got on site after 10 days of my joining. But obviously, I was initially I was in training, so I was being in supervision of someone some other engineers. But yes, I have to work on this because the breaker work is a bulk amount of work in industry. Second, the diploma students, the degree students who are just facing the recent examination after this COVID-19 pandemic, they will have a number of things of commissioning, testing, maintenance in their syllabus related to breaker. So it is a multi-purpose session that can be useful to all the viewers. Now you can see that one thing can when your oil, when there is a fault and the pressure generated in the oil gets the abnormal pressure, at that time there are chances that your breaker tank can get blasted. So you have this type of gas vent here to take care of that. So you can see here the chamber here in low MOCB, minimum oil circuit breaker. There is a fixed contact, there is a moving contact here, there is an arc extinguish device, there is a breather here. Now why breather is here? Say somebody will ask me, sir, breather is used in a transformer, but you can check the application of breather everywhere. So what basically breather does? When in your tank the oil is suppose I take an example of transformer. There is a tank. From tank the connection is given to Buchholz relay. From Buchholz relay it gets to conservator upperwards. It is half filled with oil and half filled with air to maintain the pressure balance. When there is a fault, the tank oil will move towards the conservator from the Buchholz relay, and at that time your air has to release or it has to go outside. Now once your fault gets extinguished, the oil will start coming down from your conservator to Buchholz relay to downstairs at the tank, and at that time once your oil gets down, there is a space created there. So again that space has to be filled up with air because already your air has got outside with gas vent. So what breather will do? Breather, it has a silica gel in the breather, so it will take a fresh air and it will absorb the moisture inside the air. Now many students don't know that every student has assumption that breather will take the dust particles and moisture both. No, breather will only deal with moisture. For dust particles, in below the breather, there is a device which is known as oil vent cup. So once my air passes through oil vent cup, all the dust particles is absorbed by that oil, and then it passes to breather where silica gel is there. It will absorb the moisture, and then the air can be there. So when I was doing a transformer PM, I was always said that, sir, when you do the preventive maintenance of a transformer, never keep the channel open. ब्रीदर जहां से ब्रीड कर रहा है, वो उस पे अगर एक डट नहीं लगा हुआ है, तो आपको कुछ कपड़ा लगा के भी वो बंद करना है, क्योंकि आपका ट्रांसफार्मर अभी बंद है और आपका एयर अभी उसमें एंटर नहीं होना चाहिए, अदरवाइज आपको बाद में मेंटेनेंस करने में बहुत दिक्कतें आएगी. सो this care we have to take care in industry. Many people don't know this application, so please understand. और ऐसा भी नहीं है कि मेरा सिलिका जेल है जिसका कलर जो है मेरा ब्लूइश में से पिंक हो गया है, तो मुझे इसे डाल देना है. वी डू नॉट डू दिस इन इंडस्ट्री. जब भी हम पीएम करते थे, तब हम एक कपड़े का चद्दर रख के आते थे, जिसमें हम सिलिका जेल को निकाल के, जो पिंकी सिलिका जेल है, उसको धूप में सुखाने के लिए रखते थे. This we did for 2 or 3 times. Once it regained the color, we will fill it back after the PM is over. While I did a transformer PM, it took suppose say 5 to 6 hours for our team to complete the transformer maintenance. और अगर इंडस्ट्री में काम करना है, आपको पे बढ़िया चाहिए, तो आपको धूप में काम करना, ये सब चीजें भूल जाना है. आपको सुबह में अगर ट्रांसफॉर्मर पीएम का परमिट आता है, तो यू हैव टू, आपको ट्रांसफॉर्मर पीएम में इंजीनियर वॉच करने के लिए जाएंगे, डीटीज जो है ऊपर सीधे चढ़ जाएंगे ट्रांसफॉर्मर के ऊपर. अगर धूप लगती है तो वो लोग ऊपर एक अम्ब्रेला रख के काम करेंगे और सीधा आपको बोलेंगे कि ट्रांसफॉर्मर टैंक के अंदर घुस जाओ. और टैंक इतनी बड़ी रहती है 50 MVA की, कि जिसमें 5 जन बैठ के काम कर सकते हैं. यू हैव टू ऑब्जर्व द ऑयल लीकेज इज देयर और नॉट. ऑयल लीकेज आपको कपड़े के साथ चेक करना है, आपको एमओजी का मैग्नेटिक ऑयल लेवल गेज का लेवल चेक करना है, आपको ऑयल टेम्परेचर इंडिकेटर का रीडिंग चेक करना है, आपको वाइंडिंग टेम्परेचर इंडिकेटर का सेटिंग देखना है, आपको मार्शलिंग कियोस्क से जो कनेक्शन आता है वो सब आपको लेना है. और अंत में इंडस्ट्री में वेरी इंपॉर्टेंट है, अगर आपने एक चीज नहीं की, तो आपकी पीएम शीट है, वो आपके हायर अथॉरिटी आपको क्विकली रिटर्न करेंगे. यू हैव टू टेक द मेजर when you do the preventive maintenance at HT motor side or LT motor side or transformer side. So अगर आपका स्टार पॉइंट अगर लगाया हुआ है, तो वो आपको निकाल के मेगर लेना है. तो ये सब चीजें इंडस्ट्री में ध्यान रखती हैं, क्योंकि मेगर के बिना कुछ काम पूरा नहीं होता. Now that simple megar is replaced by PI value, the ratio of the megar of 60 second to 1 second, or you can even upgrade in minutes also. So this type of things we have to take care. So these things we should be careful while working on it. अभी मैं जब पढ़ा रहा था ये चीज, तो मुझे एक स्टूडेंट से मुझे क्वेश्चन पूछा कि सर, आप जिस मोटर पे काम कर रहे हो और जिस ट्रांसफॉर्मर पे आपने पीएम लिया है, सपोज वो 11/440 वोल्ट का ट्रांसफॉर्मर है, तो आपका वो ट्रांसफॉर्मर तो इनकमर 1 था. तो इनकमर 1 अगर बंद हो गया, तो इसका मतलब इनकमर 1 के साथ आपका जितना भी मोटर चल रहा है वो सब बंद हो गया. लेकिन ऐसा नहीं होता है. क्यों नहीं होता है? क्योंकि देयर इज इनकमर 1, देयर इज इनकमर 2, एंड इन बिटवीन देयर इज अ बस कपलर. सो व्हेन बस कपलर इज ऑफ, बस कपलर इज अ ब्रेकर, व्हेन बस कपलर इज ऑफ, इनकमर 1 एंड इनकमर 2 आर सप्लाइंग देयर सेपरेट सेक्शन. इनकमर 1 की जो 50 मोटर है, वो इनकमर 1 ट्रांसफॉर्मर 1 मेरा फिट कर रहा है 11/433 वोल्ट का. नंबर 2 जो मेरा है 11/433, वो भी 50 सपोज मोटर को अपनी केवीए कैपेसिटी के हिसाब से फिट कर रहा है. अभी मान लो कि मेरा इनकमर 1 का मैं पीएम ले रहा हूं, तो मेरा बस कपलर ऑन होगा, वो इनकमर 1 का ट्रांसफॉर्मर का जो ब्रेकर है वो ऑफ होगा, उसको मैं निकाल के बाहर रख दूंगा, वर्क टू परमिट का कार्ड रख दूंगा, और पीछे जाके उसके बंद करने के बाद उसके अर्थिंग रोड को मैं डिस्चार्ज कर दूंगा. लेकिन थ्रू माय बस कपलर मेरा इनकमर 1 का बाकी सब लोड उसमें ऑन रहेगा. वो कोई भी दैट एनी टाइप ऑफ लोड विल नॉट बी ऑफ, because my bus coupler breaker is on. So now ये सब चीजें जो आती है, उसको इंडस्ट्री में बोलते हैं चेंज ओवर सिस्टम. तो जब इंडस्ट्री में कोई बच्चा जाता है, तो ऑटो चेंज ओवर सिस्टम भी ध्यान में लेना है. बीइंग अ स्टूडेंट, while I was under Oja sir of my ME in BBM, we can see the practical exposure. But what actually practical exposure does in life? Practical exposure will give you a confidence that this thing is that, क्योंकि इंडस्ट्री में आपको टाइम नहीं मिलता है. इंडस्ट्री में आपको बताते हैं कि ये टाइम लिमिट में आपको पीएम खत्म करना है तो 4 घंटे में आपको खत्म करना पड़ेगा। अगर आपको बैटरी प्रिवेंटिव मेंटेनेंस खत्म करना है तो आपको एक टाइम लिमिट दी है, उसमें आपकी ग्रेविटी मेजर हो जानी चाहिए, वोल्टेज पीएम शीट में रीडिंग, क्योंकि टाइम एंड एफिशिएंसी। सो एक मैनेजमेंट में बोलते हैं टाइम एंड मोशन स्टडी। आप जानते नहीं हो लेकिन इंडस्ट्री में आपके बॉस आपके नजर रखाए हुए हैं, वो अपनी कैबिन से भी आपको वॉच कर रहे हैं कि आप कब क्या कर रहे हो, क्या काम कर रहे हो। एंड वंस as an engineer you establish yourself while giving answer to your technicians, as while technicians you are able to handle those faults, those unwanted sequence in life or unwanted trippings in industry। फिर आप बताइए नौकरी किसके लिए नहीं है? नौकरी सबके लिए है, लेकिन हमें वहां जाके अपने अपने आप को एस्टेब्लिश करना पड़ेगा। देयर इज अ जॉब फॉर ऑपरेशन, मेंटेनेंस, automation and protection. These are the four relay testing and breaker testing. It comes under protection domain. Preventive maintenance, maintenance, breakdown maintenance, operation and maintenance department comes under this domain. The device operating and through my PLC SCADA system, it comes under automation. So अगर किसी बंदे में ये 3-4 खूबी एक साथ है तो समझ लीजिए कि वो इंडस्ट्री के लिए गोल्ड है। अगर आप जब इंटरव्यू में जाएंगे तो आपको अगर पीएलसी आता है तो प्रोसेस इंस्ट्रूमेंटेशन में फिट आ जाएगा, लेकिन वो जानते हैं कि ये बंदे को तो ये सब चीजें भी बहुत बेहतरीन आ रही है, फिर वो आपको बताएंगे कि साहब जी बताइए आपको कितना पे चाहिए। मैं हमेशा अपने स्टूडेंट्स को बोलता हूं कि लोग बोलते हैं कि सैलरी नहीं है, जॉब नहीं है। आप जॉब के हिसाब से अपनी काबिलियत जब जनरेट करेंगे तो जॉब्स आर ऑलवेज देयर। मूविंग नाउ फास्ट बिकॉज आई वाज जस्ट शेयरिंग द इंडस्ट्रियल एक्सपीरियंस। तो मिनी मोबाइल सर्किट ब्रेकर, as I already explained, the maintenance process I already explained of one of the breaker requires less quantity of oil, requires smaller space, possibility of fire and explosion, oil deterioration rapidly. The big thing I found in MOCB is the oil deterioration or carbonization, that we have to deal it with rapidly. We have to send those samples in the testing plant and got all those things. SFC breaker, electronegative. It is the ability of an atom to attract and hold electrons. Such gas have high dielectric strength. It forms a negative ions. Negative ions are heavy and immobile, so they do not flow safely. Hence, SFC gas has a very high dielectric strength. Very important breaker. Generally, in switchyard you find this type of breaker. It has a very good dielectric strength. It is powered in liquid form. And you can see here that where the fixed contact and moving contact separates, the SFC gas inlet comes here and it gets around the contact surface. I have told you that I will be passing one video after the presentation is completed of exactly how SF6 breaker is operated and maintained in industry, and BCB and ACB also. So under normal condition the contacts are closed. On the occurrence of the fault, the contacts are open at the 0 point. The SFC flows over the arc and creates the negative ions, and rapid dielectric strength is built up and the arc is extinguished. Silent operation, compact size, very short arcing time, no risk of fire. Disadvantage, costly, requires conditioning of SFC gas. Some other issues we have to deal with. Now this is very important slide to me. आपको इंडस्ट्री में जब फॉल्ट होता है तो अगर ब्रेकर से पहले आपने आइसोलेटर को गलती से भी ओपन कर दिया तो आइसोलेटर का कॉन्टेक्ट जो है इतना सफिशिएंट नहीं है, उसकी कैपेसिटी नहीं है कि वो जो इतना हैवी इंटरप्शन में जो पोटेंशियल डिफरेंस जनरेट होगा वो सहन कर पाएगा। इट विल इमीडिएटली रिजल्ट इन फ्रेश ओवर। सो जब आप ब्रेकर फॉल्ट में ओपन होता है तो सबसे पहले आपका ब्रेकर ओपन होगा, उसके बाद आपका आइसोलेटर ओपन होगा। और अभी किसी बंदे को उस लाइन पे काम करना है तो आपका यहाँ से ड्रेन होना पड़ेगा, वो लाइन को आपको डिस्चार्ज करना पड़ेगा। जो हमेशा मेरे पास वहां पे अर्थिंग रोड रहता था हर सबस्टेशन के पैनल के पीछे डिस्चार्ज करने के लिए। नाउ जब आपने क्लोज किया और आप इसको अर्थिंग स्विच को क्लोज करना ही भूल गए, देन यू हैव इनवाइटेड अ लाइन टू ग्राउंड फॉल्ट इन योर इंडस्ट्री। सो उसकी सीक्वेंस है कि अभी पहले अर्थिंग स्विच को आप क्लोज करो, बाद में आप आइसोलेटर लो और बाद में आप ब्रेकर लो। So you have to maintain the operating sequence. Isolator operates whatever the sequence I have told here, so I can immediately move to the testing. These are some circuit breaker controls. Your breaker will be dealing with different types of relay. You see the motor protection chapter, which is mentioned in Ojas's book. Different types of motor have a different fault and abnormal phenomena. So for relay overload, you have a different setting. For the short circuit fault, you have a different setting. For the negative phase sequence current, you have a different setting. But all those commands are directly giving to a trip circuit coil which is operated basically at 110 volt DC in industry. So आपको वो आप विजुलाइज कीजिए कि आपके सब रिले जो है वो पैरेलल में एक साथ पैरेलल में मोड चल रहा है और कहीं एक पॉइंट पे वो आपकी ट्रिप कॉइल को कहीं से भी कनेक्ट कर रहे हैं. So that is the important part. Auto reclosing. Auto reclosing is provided to restore the service continuity after transient fault which are not permanent, I'll call transient fault, that I have already explained. Reclosing of lines restores the supply. Test on high voltage system, I have shown that the recloser in 12 cycles is practical. It will get vary as per the standards. So अब देखिए reclosing में क्या होता है कि यहाँ जब ओवरहेड लाइन में यहाँ से मेरा टाइम हुआ तो रिक्लोजिंग इंटरवल में बाद ओपन क्लोज यहाँ पे 1, 2 और 3 साइकिल दिखाई है. So after that open close cycle, your breaker will come into a judgment कि अभी उसको ओपन रहना है या क्लोज रखना है, whether the fault is sustained और fault उसका जो है वो क्लियर हो गया है. So these reclosers are very much important. I have taken one design application, that's why I'm moving, because I'm parallelly looking at the watch also. So consider a 3-phase distribution system with single phase tap as shown in the figure. Maximum load on this single phase tap is 40 ampere, and on the 3-phase line, suppose it has a 200 ampere, so you can the fault current at F1, F2, F3, F4 are also shown. They are asking that select the rating of recloser at B. See here F1, F2, F3 and F4. All the currents I have specified the maximum fault current. So once you are going into a design part, you should know the minimum fault current and maximum fault current at every location. Now we have asked to find a recloser rating at particular these breaker at the point at the junction B. So how we are doing it? So this is the IEEE standard table for recloser selection. At the left side you can see the recloser voltage here, the voltage rating. At the right side you can see a continuous current rating and a symmetrical interrupter rating at a maximum voltage. So let's go for a design part of recloser also. So recloser at B. So what was the maximum load current at line? You can see here it was 40 ampere from here. The 40 ampere was the maximum fault current there. Continuous current rating of the recloser must be 1.25 times to 1.5 times the maximum load current to account for the anticipated load growth. So multiply it by 1.5, you will get the 60 ampere. Now you have to go to table 1 and you have to just fetch that what is the suitable rating next available. It is 100 ampere. It is acceptable. So you can see after 50 ampere the next rating is 100 ampere here. It is mentioned. Now next thing is that maximum fault current at B. We have to again back to here. At B here the maximum fault current is supposed say at F3 it is 1750 ampere. So again you have to come back into the table. Just you have got the continuous current rating. You will get the symmetrical interruption rating at the maximum voltage. Say it is 200 ampere. So at that time the 200 symmetrical ampere current we have chosen. Minimum tripping current is continuous current rating into twice plus or minus 10% tolerance you have to take. So what was the minimum current rating as we have gone through as the table? It was 100 ampere into 2 plus or minus 10%. It means that your minimum tripping current it should be of 220 ampere. Since the minimum trip current 220 ampere is less than the minimum fault current which was written in the table 250 ampere at the line end, it can protect your entire line. So thus how you have to decide the recloser rating for your reclosers which are available for the system. So why I did cover this? Because see when a diploma, ME or any candidate they enter into an industry, these things are very precious to them because number of people are knowing the basic operations of a breaker, but symmetrical fault analysis, unsymmetrical fault analysis, then the 3 states of breaker, calculating the breaker rating in MVA from the different states, calculation on design of the reclosers. This is very important. Now why I showed here section line, visualize here that this is my incomer 1 and this is my incomer 2. Now if my incomer 1 is from transformer, it is different from sectionalization, but I want to visualize that thing that I have discussed. Now if my income, I am taking my transformer maintenance from incomer 1, it means this whole load will shut off. So at that time this breaker should remain on. So from here onwards the generator can supply to its load also and from this load also. So now imagine that here in between there is a transformer, then these transformer ratings are not only made for their load only, but they are also made for the load at the second bus section of your device for the continuity of the operation. So sectionalization is very important. You have the bus coupler. In industry there is a check synchronizing relay that depends that whether you are in synchronization position or whether you want to go out of synchronization. For that SK11 relay was used when I was there at industry. So sectionalizer are used in the bus bar so that fault on the section of the bus bar will not complete shut down. I've written in whatever the things I have mentioned. Now testing. Circuit breaker tests are conducted to prove the ratings of the circuit breaker. The following short circuit tests are conducted. Now see, don't mash up with this circuit breaker testing with type test, routine test, development test, and commissioning test. They are a bunch of a different tests. Now, when at the manufacturer premises, you have to decide that whether you want, because in breaker the lethal fault is a three-phase dead short circuit, right? So you have to आपका ब्रेकर बढ़िया बना है कि नहीं वो चेक करने का एक ही रास्ता है कि ब्रेकर पे टेस्ट शॉर्ट सर्किट टेस्ट कंडक्ट करो. लेकिन ऐसा हुआ कि अगर शॉर्ट सर्किट टेस्ट में अगर आपका ब्रेकर फेल हो गया तो सोचो कि आपका जो अल्टरनेटर जो लैब में है उसकी क्या हालत होगी. तो यू कैन सी द डायग्राम हियर and the disadvantage and advantage. IC standards definition from a direct test is as follow: a test in which the applied voltage, the current, and transient and power frequency recovery are all obtained from a circuit having a single power source. A big definition that all is obtained from a single power source. It means कि आपको जितना शॉर्ट सर्किट करंट टेस्ट करना है वो आपको आपकी लैब में जनरेट करना पड़ेगा. This is a disadvantage of direct testing of breaker. आपको ये व्यवस्था वहां पे करनी पड़ेगी. A direct test is on where a three-phase circuit breaker is tested on a three-phase system and at short circuit MVA level equal to its full rating. In other words, this is a test where three-phase circuit breaker is tested on three-phase circuit and full current and full voltage. It should be obvious that testing a circuit breaker under the same condition and which is going to apply is the ultimate demonstration for the capability of the breaker. I will show you the diagram while discussing all those things. In direct testing, the short circuit tests are conducted in short circuit testing station or field type stations or laboratory type station. It has various elements: short circuit generator, short circuit transformer, master breaker, making switch, capacitors, resistance, and reactance. So this is a layout. Now you can see if your breaker fails here while test, immediately master breaker should come into the picture. अगर ये नहीं होगा आपके यहाँ तो ये सीधा इसको लेके जाएगा जनरेटर को. सो आपको यहाँ की जो चिंता है वो यहाँ का जो जनरेटर साइड का रिले जो वो ऑपरेट करना पड़ेगा. वर्स्ट केस ये नहीं करना है. इसलिए जो मास्टर सर्किट ब्रेकर जो कैलिब्रेटेड ब्रेकर है, in every condition while testing the breaker in your manufacturer premises here, it should operate. Here it is written that the reactor L is for controlling the short circuit current, and this is that reactor here, L or X. C, R1 and R2 are to adjust the transient recovery voltage. You can adjust your transient recovery voltage with the variable settings here, and obviously it is given in direct testing. The disadvantage is that you must have the big capacity alternator with the prime mover at your premises. That is a disadvantage of the direct testing. So to test the high voltage circuit breaker, direct testing using the power system or short circuit alternators are not feasible. It should have a large capacity of stations. Direct testing facility available at CPR, a high power India is 2500 MVA capacity at 72.5 kV, and in three phase at 1400 MVA capacity up to 245 kV in single phase for testing of circuit breaker. Now the second idea came that why to test all the three poles of the breaker simultaneously? Could we test one pole individually? हम एक पोल को अलग से टेस्ट कर सकते हैं तो इतना हाई पावर हमें जनरेट नहीं करना पड़ेगा. There came the indirect testing methods. So limitation of high voltage testing, the limitation of direct testing using the power system or short circuit alternator are as follows: high cost of installation of testing station, availability of limited power for testing of high voltage and extra high voltage breakers, require high power for testing breakers, flexibility of system availability is limited. So unit testing. The IC standard definition of unit testing as follows: the test made on a make or breaking a unit or a group at the making current or a breaking current specified for the test on the complete pole of the breaker. Now we are not talking of three pole. Now we can talk about a complete single pole unit also in unit testing. That's why it was named as a unit testing. Unit testing means testing one or more units separately. Generally, high voltage circuit breakers are designed with several arc interrupter units in series. Each unit can be tested separately. From the test result of one unit, the capacity of the complete breaker can be determined. With this method, the interruption units are tested at a part of rated voltage of the complete breaker. This method is recognized by the IC standard. But one more major problem remains: the influence of the post-arc conductivity on the voltage distribution across the units. That we have to be careful while conducting this type of test. Synthetic testing is an alternate equaling method of testing of high voltage breakers and is accepted by the various standards. In synthetic testing, there are two sources of power supply, current source and voltage source. The current source is a high current, low voltage source. It supplied short circuit current during the test. The voltage source is a high voltage, low current source. It provides a transient recovery voltage. You can see here the basic circuit for testing circuit breaker. When switch S is closed, short circuit current I flows to the breaker B, and when the test breaker B begins to open, an arc voltage BA, it is shown here, appears across the breaker terminal. At the current zero, when the arc is extinguished, a BTR, a transient voltage, will be produced here across the breaker, whose form is determined by the generator characteristic and the circuit constants L and C. The breaker has to withstand the transient voltage if it is to clear the circuit. Now, and it is dealing with the unit level. You can see the difference here. So in actual practice, during the period of a main short circuit current flow, there is comparatively small arc voltage appears across the breaker, and that during the period of transient recovery voltage, very little or no current flows to the breaker. Therefore, there is no need to use a single high power source. Instead, the current can be supplied by a comparatively low voltage source, since the arc voltage is usually very small, 1 to 3% of the rated voltage of the breaker, and the voltage can be applied from low energy, high voltage, low current source of the point of current 0 to simulate the transient recovery voltage in this type of case. Advantage of synthetic testing: the breaker can be tested for desired TRV and RRRV, transient recovery voltage and rate of rise of voltage. Recovery, then the short circuit generator has to supply current at a relatively less voltage as compared to direct testing. Both test current and test voltage can be independently varied. With this method, a breaker capacity MV of 5 times that of the capacity. Synthetic testing is a non-destructive nature, and therefore they are ideal for development test purpose, where the ultimate limits of the device can be explored without destroying the test model. I am showing just a rating to you. This is an application, Airblast circuit breaker. See, here it is written, it is used up to low voltage of 1000 volt. But in many industries where I visited, even after my master's, I completed a master, I normally found air circuit breakers in most of the industries up to 415 volt. So in industry, you will be dealing with an air circuit breaker which is operated for an low tension motors, operated on 415 volt, and the rating of the machine is between somewhere near 90 kilowatt to 160 kilowatt. For that, this type of breaker are used. Tank type of breakers up to 33 kilowatt now obsolete. Say frankly speaking, in the industry which I visited, I didn't see the MOCB there, MOCB or BOCB, because there was a maintenance issue of minimum oil circuit breaker, the carbonization issues in the oil, the dielectric strength of the oil, the BDV check of the oil. All these issues were there in case of this OCBs. That's what the issue. Air circuit breaker, I already told that Airblast circuit breaker, it is restricted to the furnace services or the traction services. I also explained that why traction they are preferring Airblast circuit breaker, because they need a compressed air, and compressed air is not only used for Airblast circuit breaker to raise the pento of your vehicle or train. There also the air is used to run the wipers in front of your driver locomotive. Their air is used to just play the horn of your device. Also the air is used. So some pneumatic devices already is used there. So in that case, it is economical. Airblast circuit breaker has a good arc quenching properties also. That's why they are used. You will majority find SF6 breakers in your substations. Wherever the industry you are working, you will find this SF6 circuit breakers. Now for vacuum circuit breaker, I already told that I was dealing vacuum circuit breaker. Here it is written 11 kV and 33 kV. Obviously, if your company distribution level is 11 kV, you will be using an 11 kV VCB. If your company distribution level, in my plant, I was having a distribution voltage of 33 kV. Everywhere in plant, you will find a 33 kV voltage level. So from Ichhapur, suppose line 1 and line 2 is coming, the 220 by 33 kV, the 33 kV was for the bus voltage level. So my generation is 11, so 11 to 33 was my bus voltage level. But one thing to add, that your HT motors, the motors which is greater than 160 kilowatt, is also operated by vacuum circuit breaker. So before going to this question answer round, I'll just conclude for those viewers, those faculties, those diploma students, those degree students, those MA students who are watching me live, that see, in industry, I'm again repeating, in industry there are basically 4 zones of operation. One is an operation department. They will only do the duty of de-energizing, energizing. And in a particular one day, they have a number of devices to de-energize and energize. Uh, some of the engineers or operation were given a bit role in a control room to monitor on a SCADA screen and to do the needful at the SCADA screen. Number two, the maintenance division, a big division in industry. Every day, a morning, a bulk amount of preventive maintenance permit is dispatched. A preventive maintenance for LT motor, a preventive one team will go with a 3 or 4% for preventive maintenance for HT motor. One team will go for preventive maintenance for a lead acid battery. One team will go for preventive maintenance of a UPS battery. So they need a bulk requirement of this type of category. Third zone, a protection zone, where an engineer should be sound enough to deal with all the relays, right from the beginning, from CDG to attracted armature type to microprocessor based relays to static relays. So they should be acquainted with testing of all these relays in a testing station. So testing and protection engineer, that is one requirement. And number four, an automation engineer who is knowing that how to operate my device, how to change my operating path from my PLC SCADA programming and automation programming, how to operate my process control plant from the view of automation. And if in an industry, if any diploma person, like for a technician job, for any degree or ME student, for an job of an graduate engineer, if they find a multiple qualities that yes, this he or she has a reserve capacity, he also knows the operation and maintenance principles, he bit knows regarding the automation also, and he is sound at he knows little bit of, so sound in one area, a master in one, and knowing of rest areas. This, according to many DGMs of friend of mine, it is a present requirement of industry, because what they will do, they will pull out your other skills, your communication skill, and one day they will make you a smart deputy general manager of future in an industry. So when we come to a job aspect, never think negative in life, never think negative to any people, to any situation, that this cannot be done. It can be definitely be done, but it needs a lot of patience effort. It needs a lot of reading, and it needs a vision that I want to go inside this industry, or I want to have a job in industry. That presently, what are the things which are required for me? So with this, I think so. The time limit given to me, it is nearly 3:27, and if some question is there, I'll be happy to answer it. And I've already told that if time limit is short, and my mail address is klmgcs@gmail.com and klmokaria@gecb.ac.in. That is, that GECB stands for Government Engineering College Valsad. I've already given it to Hital madam, and I'll be if you have any query, you can send me at klmokaria@gecb.ac.in. And I have told you that later, I'll today evening I'll be emailing some best videos to Hital ma'am, to give all the participants, that you can live at your home visualize that how the breaker maintenance is done of VCB or ACB or an SF6 breaker, or how the maintenance process is carried out in industry.
Thank you very much. It's a very informative session. We have some questions from our students. One student from our diploma electrical.
Hital ma'am, please speak loudly.
Okay, I repeat.
Yeah, now audible.
There is one question from our pre-final year diploma students.
Yeah.
His name is Bert. His question is, for an resistive load and inductive load considered for switching operation of circuit breaker, switching of which load is difficult and why?
Yeah, it's a good question. Say now the inductive load you pick. You suppose diploma students that do not have not acquainted to MATLAB, but you find that how that minus L di by dt and all those things will come into the picture. But in breaker, you are very fortunate that while you design your breaker, you will having the design that the steps I shown, which included the inductive load and resistive load design combinedly. As even if you have a simple resistive load, not only this type of circuit breaker, or even you get the static breaker. Nowadays people use the static breaker also. In that case also, the resistive design is very simple. because you do not have any other issues like that the student is asking. But regarding the breakers, I have explained. It is fantastically working for your all combined types of load, resistive, inductive, capacitive, all loads. You say the second thing I want to add, the main thing in the breaker is identification of the natural 0 point. Fine. So if as one of the phenomena that naturally occur in the Airblast circuit breaker, that you got shifted your natural point before the zero. But if say in some polluted atmosphere, if you have this impact, you should have some other solutions of ZCD and all those things before that breaker. That is also there in industry nowadays. It is there.
Second question from our faculty, Purvesh Swalan sir.
Yes, sir.
Second question from our faculty, Purvesh Swalan. His question is, after the occurrence of fault, how many times reclosing is done?
Now, say it is very interesting that generally the thumb rule is that you have a 3 or 4 shots of recloser operation, and it is not only say one sequence is there TO15CO 15CO. It is suppose written on the name plate of breaker. So CO, suppose a CO5 and CO. So it means it has a 5-second gap of between that close open sequence. In a thumb rule says that generally it takes in transmission line it takes 3 to 4 shots of recloser while opening and closing. They are waiting that the air around the breaker will take care of the transient fault to get extinguished and kept and keep on the breaker into the service. But the sir who has asked the question today evening, the material which I am sending in that, I'll be sending one recloser timetable as per IEEE standards, that for EHV line, for HV line, what is the basically a time limit and the sequence for that.
Okay, sir. Now, next question from our faculty. It's Risil Bhagat, sir. His question is, why asymmetrical braking current is higher than the symmetrical braking current in a circuit breaker?
Now, say very interesting. Say when you do a fault analysis, whether it is a dead short circuit as you told, or whether it is a line to ground fault or any other fault. Now, it is very important that where is the fault location. At the present, forget the criteria of asymmetrical and symmetrical. The fault location, your per unit equivalent circuit, and the evolution of the current from that is very important. In whatever the studies we have studied, sir, in the breaker concept, in most of the cases, the 3-phase dead short circuit. Fine. In other concept, I will not say this sentence. In other concept, you have to see that in sometimes you say that unsymmetrical fault. If I do all my calculations, I get my base MVA, I put it in a single unit diagram, and I'll get the answer due to the value of the fault current, due to the location, and due to the reactance value at that particular location. That there is a key that the value will be higher or lesser. But in case of breaker, in majority of the IC standards or other standards, you will find that the key will be lying with 2 points. Number one is a 3-phase dead circuit, and number two, that your XD double dash, that is the subtransient cycle current. This current is only there in the presentation. I just told that it shows for only 2 cycles. That's why in my presentation, what I covered, instead of showing a generator, a transformer, a line, a unsymmetrical fault, a symmetrical fault, then the fault calculation for each and individual unit of generator, transformer, transmission, and then preparing a per unit diagram for that, and then finding the ultimate reactance, and then finding the current, I directly pick up the pinpoint, and the pinpoint was the first 2 cycle current of the breaker, and according to that, I got the breaker rating in MV. That's the key.
Now, there are no any questions. There is not a question. There is a feedback from our Oja sir. I want to pass to you. He messaged me. Okay, application and maintenance of breakers are nicely covered with respect to industrial applications. Very good job by the Kashyap sir. And second, once again, have passed the message. Preventive maintenance required in power industries and industrial experience are covered nicely. Few teachers have this knowledge and industrial experience. I am impressed. So this is the feedback from the Oja sir. Thank you, Oja sir. It's
Actually, Ethel, I'm giving the message to the audience that with the due respect, I remember the days under which I studied under Uja sir. And actually, the previous lecture, due to my not proper knowledge of operating the software, I missed sir's session. So he is very close to my heart. The gurus under which I learned and which I grew up, I do respect them, and that their blessings are very much important for me. One thing I have to share with the audience that when I got the award for 2019 for off-grid solar PV stations establishment at Surat region. So same you in industry or in this type of design we have to pick up a shortcut. When we were deciding a cable rating, say whether we have to go for a 4 square mm or 6 kml, so in that you should have a ready-made industry table for that. कि आपका जितना भी मान लीजिए कि आपका जो जो करंट रेटिंग जो है वो किस पे डिपेंड करेगा, तो आपके पास मल्टीप्लाइंग फैक्टर है, जैसे HP into 1.5 gives you full load current. So in industry, according to the motor, the capacity rating is there, a static capacity rating is, everybody is there, but you'll be hands-on using these things while you enter into the industry. That we were using at that time.
Last one question from the Devans once again. It's a pre-final diploma electrical students. His question is why current chopping is not common in oil circuit breaker.
Say, in my slide actually, I have written a current chopping phenomena in ABCB. But you just visit the internet and you go through, you will find some literatures on VCB also. Fine. That, but you see the properties of other or the principle that how you are supposed to compare the ABCB and your VCB. So the important part is when dealing with the low inductive current. Suppose that low inductive current means transformer at no load. That is that phenomena. And how your breaker opening mechanism behaves in that manner and how you are rapidly building the dielectric strength, that was a key for a current chopping. Now in case of vacuum bottles of BCB, you talk to the industry people, the technician. In the technician language, they will say, "अरे भाई vacuum bottle में तो वो होने ही नहीं देगा." तो होने नहीं देगा का मतलब जो है वो मैंने PPT पे आपको समझाया था. It is not like that. But what was the exact meaning of why that that rapid dielectric strength builds to avoid the current chopping phenomenon is there? Yes, in some higher rating breakers you will find in some other breakers also, that I'll be passing to I think so Devanshu na. Devanshu's email address and many other participants' email address at today evening with videos for more details.
Okay. So now there is no another question. So as per time permit, we conclude our session, our webinar. So I once again on behalf of Paru University, I would like to say thanks, Kashyap, for enlightening us the circuit breaker and their functions, their maintenance, and then working. Thank you.
And very much thank you to Parul and all the viewers who are listening me. And today definitely, Ethel ma'am, I will be mailing you some videos and with that session that how the current chopping in other breakers were built. That literature I am sending today because it is a big topic. So I'll be that sending also. And please give me the feedback on the same email from which the data is sent.
Sure.
Thank you very much. Thank you very much.
Thank you.
My pleasure.
Thank you. Bye.